Hello. We're going to be going through the 10 heat problems practice worksheet. This is all about shoring up the math we've been learning in calorimetry this week. And I'm starting on the very last page. The first several pages are just notes and example problems that are showing you how to do some of these types of problems. But the actual questions are at the very back, right underneath the specific heat capacities table for the different substances. So I've picked a couple problems to give us some variety and hopefully to demonstrate some different methods you're going to have to employ or things to be aware of. So we'll start with number 3. Number 3, how many grams of copper could be heated from 20 Celsius to 75 Celsius if 1200 calories are applied to it being the copper in this case. So I'm going to go ahead and start. I always like to start by taking out the numbers from this word problem. So I've got 1200 calories, 75 Celsius, and 20 Celsius. So I'm going to write those down here. 1200 calories. And I'm going to go ahead and tell myself which variable that is. I see calories. Calories is the key. Calories is always a unit of energy, and we use Q to represent energy. I see two different temperatures. Now, the most important words in this sentence are from and to. If I know that it was heated from 20 Celsius, then I know that's the temperature it started at. So we'll call that the temperature initial. Little I there. It was heated to 75 Celsius. And that's going to tell me the final temperature. Now there's one more really important word in this word problem that's going to give me another number, even though it doesn't look like it, and it's that word right there, copper. Copper tells me the substance I'm heating, and it allows me to look up the specific heat. And fortunately for us, there's a table of specific heats at the top of this page. And if I look next to copper, the specific heat of copper says so it's 0.092, and if I look on the table, those are in calories per gram Celsius. And specific heat will be represented by a C. A lot of information in this one problem. Now, I know my equation. My equation is going to be Q. Let me actually write the Q the way I did before. Q equals MC delta T. Q equals MCAT. That's how I remember that. So, with all these givens, I should be able to plug those in. I do have a Q. I have 1200 calories equal to M. M I don't have, but if we go check the problem, it says, this is important, how many grams? So it's definitely what I'm looking for. I'm not supposed to know grams, I'm supposed to find grams. So I'm going to leave that. I'm going to leave that as M, since I don't know a number for it. C, I'll put a little parentheses because I'm multiplying. The C that I looked up for copper was there. It was 0.092 calories per gram Celsius. And the delta T, which is always final minus initial, is going to be 75 Celsius minus 25 Celsius. And that should do it. So now I have all my numbers in place. And if you look, calories and calories should cancel. That's good. I want all my units to match my specific heat. Celsius and Celsius should cancel. So the only thing left is grams, which is fine because I'm looking for grams. I'm looking for mass. Okay, so I've canceled my units, so let's come on down here. I'm going to have 1200 equal to M times 0.092, and then I have 75 minus 25. Before I can multiply those, I need to subtract. So I'll subtract 75 minus 25 and get 50, which I have to multiply by 0.092. So let's do that really quick. 50 times 0.092. And my calculator tells me that is a 4.6. Keep the M, 1200. Okay, last algebra step. I have to get that M by itself, so I'm going to remove the 4.6 by dividing by it. So I just need a 1200 divided by a 4.6. And the calculator is going to tell me that that is 260.86. I'm going to round that to 261. And it's a mass, and I found that my mass is supposed to be in grams. Okay, there's your answer. So, if I were to write this in a sentence, assuming I wanted to do such a thing, how many grams of copper would be heated from 20 to 75 if 1200 calories were applied? It would take a 261 gram mass of copper that would need 1200 calories to boost it from 20 to 75. So now if you ever wanted to know how to heat your copper to 75 Celsius, you have the math to do it. Good stuff. All right, we're going to go on to another problem here. What would the temperature change by? What would the temperature change by if a 90-gram piece of hot iron cooled by losing 200 calories? I'm going to approach this exactly the same way as I did the previous problem. I'm going to go through and I'm going to underline everything that looks like a given or looks like a number. So I have 200 calories, I have 90 grams, and I learned before that it matters what material I have. So I'm going to underline iron because that's going to allow me to look up iron-specific heat. So let's write some of these down. We have 200 calories, which I know is a Q, or an energy. We have 90 grams, which I know is a mass. And I have iron, so I'm going to look on the table. Iron. Iron on my specific heat table has a specific heat of 0.11 calories per gram Celsius, which I know is my specific heat C. Looks like that's all I need. And they want a temperature change. Now, don't forget our equation, Q equals mc delta T. So let's plug these in. Q was 200 calories. Put that right there. 200 calories. Equal to M. This time I do have M. It's 90 grams. Times specific heat C, which is 0.11 calories per gram Celsius. And delta T is not given. So I'm going to leave it as delta T, which is exactly what they wanted. So what would the temperature change by? What temperature? So they're asking me for temperature, so I don't actually need to know it because I'm going to solve for it. Okay? Well, let's do what we can. I've got 90 times 0.11. All right. Oops. Which should be 9.9. The grams are going to cancel. So are the calories, by the way. So I should be left with degrees Celsius, which is what I'm looking for. So I'm going to get 9.9 delta T when I multiply those two things together. And I'm going to get 200 on this side. And then I'm going to get T by itself. I have to divide 9.9 on both sides. Good. And all I just need to know what that is, 200 divided by 9.9. And I get 20.2 Celsius. And they asked for a delta T. They're not asking for a final or an initial, so this is just it. It's how much I changed by. But I need to be careful here. I've actually messed up one of my givens, and I'm going to go look at it. It's right there. 200 calories. I ignored something important in my original problem, which is this word right there. Losing 200 calories. If you see that word, you need to make sure that you're calories are negative. I'll put a big negative in front of that 200. I am losing those 200 calories. They are going away. So I will be 200 calories less, or my iron will be 200 calories cooler afterwards. Or less energetic, I suppose. So I'm going to take that minus, put it here. It's negative 200 there. It's negative 200 there. Carry it all the way down, which means my final answer will be negative 20.2 Celsius. Very important to put that in there. Otherwise, you might think, oh yeah, this hot iron is getting hotter. But we're cooling it down. We need to make this hot iron go down by 20 Celsius. Lose that energy. Okay, that would definitely be points off if I had put that on my test. So 2 different problems, but the same sort of principles involved. We started by finding our givens, our numbers. Sometimes the number was like this, our specific heat, and we had to look it up on the table. We looked for keywords like losing, and that tells us to put negative signs in. And then also, we found out it was very important to look for keywords like from and to, which are going to let us know whether we have an initial temperature or a final temperature. As opposed to this one over here said the temperature changed by. If you see the word by, you're talking a delta T, not a T initial or a T final. You just have the whole delta T. Okay, I hope this was helpful. Good luck finishing the rest of this worksheet, and I will see you next time.